Hello out there in video land, pre-calculus fans. It's the 28th and you'll be watching this video either on the after class on Friday the 28th after the bonfire, 29th Saturday, or the 30th on Sunday. And we're talking more about verifying trig identities. So we have moved on from actually simplifying. So we're going to look at verifying trig identities. So the main difference is when you have an identity, you have two things that are equal. So you must have an equal sign. And in these problems, you will have a left side expression equals a right side expression. And your job is to tell how we get from one side to the other and verify that it's true. So some of them can be quite non-challenging, such as this one. Cosine t secant t equals 1. So notice I give you the left-hand side equal sign and the right-hand side. So you have to prove how to get from here to here. So the first step I taught you yesterday was rewrite the left-hand side and just stop there. Now you have to think of some trig steps, and so that we end up with a 1. So one of our toolbox entries is secant. It can be rewritten. It can stand on its head. So the secant is the reciprocal function of cosine. So I'm going to write cosine by itself, unchanged, but when I get to secant, I'm going to write it in its reciprocal form, 1 over cosine. Now I can see that these become a big fat 1. Anything over itself is 1, so we get a 1. And that is what we were trying to do. So some students don't give me this step. They just give me this equals 1. And you have to really show me how you get that, or I can't give you credit for your work. So even though it might be trivial or very obvious, you have to show me the steps to get from here to here. All right, so let me show you another one so you get the gist of it. So let's move on to a medium level verifying problem. 1 over secant x tangent x equals cosecant x minus sine x. I get a little nervous sometimes when I'm trying to verify trig IDs where you have one term. See, there's no plus or minus sign in this, so it's one term. Here, the minus sign divides this into two terms. I get a little nervous when I see one term on one side and two terms on the other. So I know I have to perform some kind of magic. So I want to introduce at this point that's a lot of times when you have one term on one side and two terms on the other, it's easier to start where the two terms are and try to go back to the one term. So I taught you that in verifying trig IDs, rewrite the left and start until it looks like, rewrite the left till it looks like the right, but it's just as valid to take the right and make it look like the left. So I'm going to go ahead and do that. So I'm going to start with this side and end up with this side. Either way, we'll verify that the trig identity is sound. So now I'm going to change to sine and cosine. Cosecant is 1 over sine. And now I'm going to add algebraically. So I want this to have the same denominator as this. So I'm going to multiply this term only by sine x over sine x. I chose that It's a 1, so it's not going to change the value, and it's going to give me the denominator that will match this denominator. So, keep it in the screen. This will equal 1 over sine x minus, now I've got a sine x times a sine x, or sine squared of x, over the desired sine x. Now I can write these under the common denominator. So, just like when you're adding fractions, the numerators combine over the common denominator. Now this is a trig ID, so if you look at your Pythagorean IDs, this is one of the versions of it. 1 minus sine squared is cosine squared. So, I have then changed this from 2 terms to 1 term, but it's not the 1 term that I want. So I'm going to keep an eye on the prize. I'm always kind of looking at where I'm going, so I'm going to keep an eye on that. And as I look at it, I see a secant and a tangent. So here's the idea that I use to get there. I'm going to take this cosine squared and write it as cosine by itself times cosine. Can I not write cosine squared as cosine cosine? And I'm going to group this first cosine all by itself, but this sine I'm going to put under this one. So how did I know to do that? Because I was looking at the prize, and the prize had a tangent in the bottom. A tangent on the bottom is the same as a cotangent on the top. So, and a secant on the bottom is the same as a cosine on the top. So that's what I'm aiming for, a cosine on the top, and this is equivalent to cotangent. All right, so I'm almost there. Looking at the prize, how can I rewrite cosine of x so that it looks like this? Well, I know cosine and secant are related, so I can rewrite cosine as 1 over the secant. They're reciprocal functions. And I can rewrite cotangent as 1 over tangent. And now I simply multiply the tops and the bottoms together, and I get 1 over secant x tangent x. And if we've lost the prize in the screen, but if you go back there, there it is. Secant x, tangent x. So again, let's see what we did. We started from the 2 terms, and we rewrote it as sine and cosine. And then we added algebraically by giving it the like denominator, sine x. We noticed there was a trig ID to substitute, and we split up cosine so that we could get the functions closer to what we wanted. And keeping an eye on the prize, we rewrote cosine as with the reciprocal function and cotangent, and then we were home free. All right, so the more of these you do, the better you will get. So it doesn't really help you a whole lot to watch me do them over and over again. So let me leave you with one to do for tonight, or just whatever day you're on, bringing in Monday morning. You try, let's see, what would be a fair one here? Let's try this one. Ready? This is a medium one, but you've seen quite a few of these. Let's do tangent t minus cotangent t over sine t cosine t equals secant squared t minus cosecant squared t. So that's what I want you to verify. And when I did this one, I remembered that in algebra, so I'll give you this clue, when we had two terms that were on top of one term, just like this is two terms, they're separated by this minus sign, makes it two terms. There's no plus or minus sign here, so it's one term. So when you have two terms divided by one term, that's the same as the first term divided by the denominator plus the second term divided by the denominator. Usually we're going in this direction. Once we have a like denominator, we use it. But here we're going to go in the other direction. So if you can rewrite these two terms as this over this minus this over this, you will see where to go from there. I believe you'll have to change everything within that new construct to sine and cosine, and you'll see it will fall into your lap. So work on this one for Monday and do me proud so that I can be amazed, shocked and amazed at your comprehension, your diligence, your work, and the beauty of it all. Are you inspired? All right, that's it for tonight. Over and out.